Hello everyone. Today I am going to explain one important topic in organic chemistry, that is electron displacement effects, right? Electron displacement effects is an important tool in organic chemistry. In order to do the questions based on mechanism, you should have idea about electron displacement effects. Okay, before going to start electron displacement effects, I will explain reaction intermediates. You should have some idea about reaction intermediates. Okay, let us start reaction intermediates. After that we will start electron displacement effects. Okay, let us start. Reaction intermediates. Reaction intermediates. See, what is reaction intermediate? I'll tell you. Let us take A is reactant. A is reactant and B is product. B is product. In this reaction, we are getting B directly from A. In the middle, no substance is formed. No undesired substance is formed. This is a direct reaction, one-step reaction, right? Let us take another reaction. This is reactant. Reactant. This is final product. This is final product. Final product. See, B dash is the reaction intermediate. B dash is undesired product. This is called as intermediate. Intermediate. Okay. In some reactions, before formation of final product, undesired product formation takes place. That undesired product is called as reaction intermediate. Okay, A is reactant, B is final product, and B dash is the undesired product, that is called as reaction intermediate. Let us see the types of reaction intermediates. Okay, I'll give you three important reaction intermediates in the tabular format, right? Let us start. First intermediate, carbocation. Second intermediate, carbene ion. Carbene ion, and third one is free radical. Free radical. See, we should have idea about these three reaction intermediates, because in second year organic and in first year organic chemistry, in the middle of the reaction these terms will come, right? In some reactions first carbocation formation takes place, in some reaction carbene ion formation takes place, in some reactions free radical formation takes place. We should have idea about carbocation and stability of carbocation, then only we can do the questions, right? Let us start carbocation. What is a carbocation? Look at this, all of you. Very simple definition for carbocation. We are not going to discuss lengthy definitions because we have only very less time, so we will go with the short definitions, right? See, observe this species. In this species, positive charge is present on the carbon. So we can define carbocation like this. The species in which carbon is having positive charge is called as carbocation. Very simple definition. The species in which carbon is having positive charge is called as carbocation. Similarly, the species in which carbon is having negative charge is called as carbene ion. If you observe negative charge on the carbon, that is called as carbene ion. And free radical, the species in which carbon is having single electron, carbon is having single electron, is called as free radical. We can give another definition also, the species in which odd number of electrons are present. How odd number of electrons? Look at this. Each bond contains 2 electrons. Okay, count electrons 1, 2, 3, 4, 5, 6 and 7. So odd number of electrons, also called as free radical, right? Okay, let us discuss some more important points, right? Great. I given first definition, carbocation, carbanion and free radical definitions. Let us see next. Once look at this, all of you. Around carbon, how many bonds are present here? Around carbon, how many bonds are present? Around carbon, 3 bonds are present. Each bond contains 2 electrons. So total, how many electrons are present? Count 1, 2, 3, 4, 5, 6. So valence electrons are number of electrons around carbon in carbocation. 6, and we know what is octet. Octet means presence of 8 electrons, but it is having how many electrons? 6 electrons only. So very important point. This is very important point. See, if you know this point, that is enough. You no need to know any other points about carbocation. This is important point. Carbocation means electron deficient species. Why it is electron deficient species? It is having only 6 electrons around the carbon. So I am writing that point, electron deficient. Very important point. Electron deficient species. Carbocations are electron deficient species, right? Okay, and hybridization of carbon, sp2 over. Once look at this. Around carbon, how many bonds are present? Around carbon, we have 3 bonds. 3 bonds means how many electrons? 6 electrons. And here negative charge is present. See, throughout organic chemistry, consider negative charge as 2 electrons. Consider negative charge as 2 electrons. This is negative charge, consider it as a 2 electrons. Now count total electrons. 1, 2, 3, 4, 5, 6, 7, 8. How many electrons are present? 8 electrons are present. Octet is present, right? So I am writing valence electrons are 8, octet is present. So we can write carbanion as electron rich species. Electron rich, because already 8 electrons are present. Electron rich. Electron rich species. Okay. Carbocation is electron deficient. Carbanion is electron rich species. Clear? Carbocation accepts electrons. It accepts electrons from others. Carbanion won't accept electrons because already it is having 8 electrons. So that is the main difference, right? Carbocations are deficient, carbanions are electron rich. Coming to free radical, right? See, free radical structure. Around carbon, how many bonds are present? Around carbon, how many bonds are present? 3 bonds are present. Count total electrons. 1, 2, 3, 4, 5, 6. And 1 electron here. 7. Total how many electrons are present? 7 electrons are present. So valence electrons are 7. Right? 8 electrons are not present. So free radicals also electron deficient. Very important point. Electron deficient. Carbocations are electron deficient and free radicals are electron deficient. Remember? Okay, right. And we have to write hybridization also. Here we wrote hybridization. See, here hybridization is sp3. Here hybridization is sp2 hybridization. Okay, right. 3 important intermediates are over. Okay, let us see another intermediate. Benzene intermediate. See, this is rarely formed. Benzene intermediate. Okay, we see frequently first 3 only: carbocation, carbanion and free radical only. But I'll give you some points about benzene. Benzene also reaction intermediate. Okay, right. Very important point. In benzene, all carbons hybridization is sp2 only. Don't consider this carbon hybridization as sp, because here triple bonded carbon is present. Students will think that this is sp, but that is not sp. This is sp2 only. This is also sp2 only. Clear? Remember that point. So this is about reaction intermediates: carbocations, carbanions, free radicals and benzene. Okay, let us electron displacement effects. First of all, I will tell you importance of electron displacement effects. See, in inorganic chemistry, if we have memory, then we can do the questions. Most of the questions based on the memory only. In physical chemistry, based on the memory, and based on the calculation ability we can do the questions, right? But in organic chemistry, if you have command on electron displacement effects, especially if you have command on general organic chemistry means these reaction intermediates, electron displacement effects and reaction mechanism only, right? If you have command on general organic chemistry, then only you can do questions, right? I am not saying all the questions based on the GOC of first year organic, but 90% questions will come based on the general organic chemistry only. 10% questions will come directly based on the memory, name reactions will come, okay? But the problem is when question will come based on the GOC, then only you may get some difficulty to do the questions, okay? Let us do some questions, right? Then you can understand, right, what is the importance of general organic chemistry. See, I am giving one reaction here. Guess where Cl will be added. I am giving the numbering here. 1 2 3 4, okay, right? Guess where Cl will be added. I'll give the time to you. Where Cl will be added. Actually, most of the students will say, sir, Cl will be added. Cl means Cl is the negative part. Negative part of the reagent adds to carbon with a less number of hydrogens according to Markovnikov's rule, right? And hydrogen will add to first carbon, but Cl will adds to third carbon. That is based on general organic chemistry. This is second year question, this is, right? Or first year question also. How this is first year question as well as second year question. See, this will comes under chemical properties of alkenes and preparation of alkyl halides of second year, right? So one reaction will come in the 2 lessons. That is the benefit in the organic chemistry, right? So okay, we can understand how this Cl will adds to third carbon after completion of our discussion, right? Okay, what is our heading? Electron displacement effects. Let us start. First, electron displacement effect. Inductive effect. Second one is hyperconjugation. Third one is resonance effect or mesomeric effect. Right, and fourth one is electromeric effect. Right. First three effects are called as permanent effects. These are permanent effects. And last effect, electromeric effect is a temporary effect. This is temporary effect, okay? Right, let us start first one, inductive effect, right? Are you ready, all of you? I completed reaction intermediates. What are reaction intermediates? Carbocation, carbanion and free radical and benzene. What are carbocations? Electron deficient. What are carbanions? Electron rich. What are free radicals? Electron deficient, right? Because again I use the definitions in this. Clear? Let us start first one, inductive effect. Inductive effect. Right. Before going to start inductive effect, I'll give you one small information about polar bond and non-polar bond, okay? Because that is very useful here, right? Basics are very important, okay? Sometimes we need basics to understand one concept, clear? That's why I'm giving these basics. Polar bond, see, the bond which is present in between two different atoms. Bond present in between two different atoms. Is called as polar bond. Sir, what is the relation between polar bond and inductive effect? Wait for some time, you will get. Okay, bond which is present in between two different atoms is called as polar bond. For example, say oxygen and fluorine bond, this is called polar bond. Polar bond. Hydrogen and fluorine, this is also called a polar bond. Like hydrogen and nitrogen, this is also polar bond. Polar bond. See, fluorine and oxygen, which is more electronegative atom? Fluorine. You know phone call? FON, phone call. Fluorine is more electronegative, after that oxygen. After that nitrogen. Remember this? This is one small code, phone call. Fluorine is more electronegative atom. What is more electronegative atom? More electronegative atom withdraw electrons towards itself. Okay, right. Fluorine is more electronegative atom. Fluorine withdraws all electrons towards itself. So fluorine will get negative charge. Oxygen will get a positive charge. Here also fluorine is negative, hydrogen is positive. Nitrogen is more electronegative, so nitrogen is negative, hydrogen is positive. So this arrow mark represents movement of electrons. Movement of electrons. See, creation of this negative charge and positive charge is called as polarization. Polarization. This is negative pole, this is positive pole. Negative pole, positive pole. Poles are creating. This is called polarization. Creation of positive and negative charge is called as polarization. Okay, remember this point. Now it is clear what is a polar bond. The bond which is present in between two different atoms. Fluorine and oxygen both are different, so polar bond. Polar bond means you have to imagine, oh, negative charge and positive charges are present, right? Right. Non-polar bond means, guess what is non-polar bond? Non-polar bond means non-polar bond, the bond which is present in between two similar atoms. Look at this, the bond which is present in between two similar atoms, oxygen, oxygen. This double bond comes under non-polar bond. Bond which is present between hydrogen and hydrogen. Okay, non-polar. All these are non-polar. Here there is no positive negative charges. Clear? Because both are having same electronegativity now. So there is no positive negative charges. Remember this concept, polar and non-polar bond, right? What is our main topic? Inductive effect. Look at the definition of inductive effect, all of you. Definition. Right, I am taking one carbon chain. You tell me, in this carbon chain, what is the nature of this bond? Polar bond or non-polar bond? This bond is present in between two similar atoms, no? So non-polar bond. This is non-polar bond. This is also non-polar. This is also non-polar. Non-polar, non-polar, non-polar. Bond which is present in between two similar atoms is called as non-polar bond. Non-polar bond. Is there any movement of electron? No. Why? Because both are carbon atoms only, na? Both are having same strength. So electrons do not move towards any carbon. Clear? So there is no negative positive charge here. There is no creation of positive and negative. But see what I am doing, I am attaching more electronegative atom to this carbon chain. Clear? Now observe this bond. This bond is polar bond. Why this is polar bond? This is present in between fluorine and carbon. Clear? So here electrons will move towards fluorine because fluorine is more electronegative. Fluorine is more electronegative. Once I'll give the numbering also. First carbon, second carbon, third carbon and fourth carbon. Once look at this. Look at this. This is polar bond, right? Fluorine is more electronegative atom. Fluorine withdraw bonded electrons towards itself. Okay. So due to that fluorine will get which charge? Guess. Negative charge. Negative. Carbon is losing electrons. Why carbon is losing electrons? Because fluorine is withdrawing electrons. So carbon will get which charge? Carbon will get a positive charge. Right? Clear? No. See, this carbon is losing electrons. That's why I am writing positive charge. See, fluorine is more electronegative. It is highest electronegativity atom, right? Its electronegativity on Pauling scale is 4, right? So it can withdraw electrons from the second carbon also. because its power is more, and it can withdraw electrons from the third carbon also. So second carbon also will get a positive charge, third carbon also will get a positive charge. Why? Because fluorine is more electronegative atom. It can withdraw electrons from third carbon also but it cannot withdraw electrons from the fourth carbon. Why? Because distance is more, distance is more. Clear? Remember this point. I'll again repeat this point regarding distance, right? Clear? So fluorine can withdraw electrons from the first carbon, second carbon and third carbon, but not from the fourth carbon. I'll explain this concept with a simple example. Let us consider fluorine as a magnet. Fluorine as a magnet. Okay, you know magnet. This first carbon, consider first carbon as first iron nail. This is iron nail, first iron nail, second iron nail and third iron nail. Imagine this magnetic power spreads up to some region only, region, right? This is the magnetic region. Within this region, if you place any iron object, then it will attract, right? Each magnet is having its attracting power up to certain region, right? Within that region, if you place any iron object, that iron object will be attracted. Clear? It is having some power up to some region only. Clear? If you place iron nail here, what happens? This iron nail is out of the region, na? So it won't be attracted by the magnet. Similarly, this carbon also away, distance is more. So fluorine cannot withdraw electrons from the fourth carbon. Got it? Right. Okay, coming to the definition. What is happening here? Tell me. Once look at this. What is happening here, all of you? Let us define what is inductive effect. Okay, look at this. Here also arrows represents tendency of movement of electrons to move towards more electronegative atom. Arrows, right? Once observe the structure carefully. Electrons are trying to move towards more electronegative atom. It is the tendency of movement of sigma bonded electrons towards more electronegative atom. It is the tendency of movement of sigma bonded. Each point is very, very important, especially for NEET students. Theoretical based questions will come. Okay, in inductive effect, sigma bonded electrons will involve, not pi bonded electrons. Very, very important. Pi bonded electrons will involve in resonance effect or mesomeric effect, right? So see the definition. It is the tendency of movement of sigma bonded electrons towards more electronegative atom. This is the definition of inductive effect. It is the tendency of movement of sigma bonded electrons towards more electronegative atom. See, very, very important point. I wrote tendency of movement only, not complete shifting. Once see this, let us consider this as a bond. At this end one electron is present and at this end one electron is present. Let us consider this is hydrogen atom, this is fluorine atom. Right? This is hydrogen atom, this is fluorine atom. In between the two, one bond is present. Within that bond, electrons are present. This is fluorine. Now, once look at this. Electron density is towards fluorine only. Okay. Tendency of movement of sigma bonded electrons. Tendency only, not complete shifting. This is complete shifting. See. This is complete shifting. Complete shifting do not takes place in inductive effect. Tendency only, tendency of movement of sigma bonded electrons towards more electronegative atom. Complete shifting do not takes place. Very, very important point. Okay, clear? Definition is okay for everyone. Let us see some other points about inductive effect. It is distance based effect. Inductive effect is distance based effect, right? Works up to which carbon? Once see this diagram, all of you. Works up to which carbon? Third carbon. See, third carbon. Works up to third carbon, works up to third carbon. And one more important point, due to inductive effect, see, negative charge and positive charge are creating or not, that is called as polarization. I explained already, right? Because of inductive effect, polarization is taking place. So inductive effect causes permanent polarization. Because of inductive effect, positive and negative charges will be created. Let us write that point. Okay, it causes, it means inductive effect, it causes permanent polarization. Permanent polarization, right? It is permanent effect. I already explained this at the beginning only. Okay, it is permanent effect. It is permanent effect. Inductive effect is permanent effect, not temporary effect. Okay, right. And fifth one is electrons present in the same orbital only during inductive effect, during I effect. I am writing shortcut, during I effect. See, what is the meaning for this? Electrons present within the same orbital only. I told you, in inductive effect, just a tendency of electron to move towards more electronegative. Just show the tendency only, it won't move. Electron present in its own orbital only. But in resonance effect, electron leaves its orbital and enter into another orbital. Clear? That is the main point. Electrons present in the same orbital only in the inductive effect. Okay, during inductive effect. Clear? Right. Okay, let us see what is a plus I group, what is a minus I group. Okay, right. Plus I groups. Electron donating groups. Electron donating groups are called as plus I groups. Minus I groups, electron withdrawing groups. Electron withdrawing groups are called as minus I group. See, questions came based on plus I, minus I groups and their order. Okay, first of all, definition is clear. Plus I group means electron donating group. Minus I group means electron withdrawing group. Let us see some important minus I groups and their order. What is the order? I will tell you. Okay, right. I am starting with the minus I groups because minus I groups examples are more when compared with the plus I groups. We know already what is a minus I group. Minus I group is electron withdrawing group, right? Once look at this. Fluorine is one minus I group. Okay. NO2 also one minus I group. Look at this. Fluorine can withdraw electrons from the carbon chain. NO2 also withdraw electrons from the carbon chain. Both are withdrawing groups only. But the difference is there. See, nitrogen can withdraw maximum electrons. For example, let us consider these three carbons are having 100 electrons. NO2 can withdraw 90 electrons from these three carbons. Its withdrawing capacity is more. Why? Because it is having a more electronegative atoms. More number of more electronegative atoms. So its withdrawing power is more. Two oxygens are there now. Oxygen is more electronegative or not, and one nitrogen also there na. So three withdrawing groups are there, so its withdrawing capacity is more. Clear? Fluorine is only one single atom, its withdrawing capacity is less. Here also consider these three carbons are having 100 electrons, but fluorine can withdraw only 40 electrons from these 3 carbons because its withdrawing power is more. This is called strength of minus I group. Strength means ability to withdraw. This is having more minus I strength. What is the meaning of more minus I strength? It is having more withdrawing power. Minus I strength is more means withdrawing power is more. So which is having more minus I strength? NO2 is having more minus I strength. Question came in the previous exams. Arrange the following groups or atoms in the increasing order of their minus I strengths. Okay, let us write some important groups or atoms in the decreasing order or increasing order of their minus I strength. Okay, let us see. Minus I strength. You have to by heart this. Some atoms or groups. Everyone should by heart this, okay, because questions came. And to do the applications of inductive effect, you should know the order. Clear? Without having idea about order, you cannot understand the applications, right? Okay, look at this. NF3, it is a powerful withdrawing group. International DOM, NF3, international DOM, okay. NF3 positive, strong withdrawing group. Its minus I strength is more. NF3 plus NR3, R means alkyl group, like methyl group, ethyl group, right? NR3 positive, SR2 plus and NH3 positive, NO2 nitro, cyanide, aldehyde, ketone, carboxylic acid. Carboxylic acid after halogens will come, fluorine, chlorine, bromine, iodine. Okay, after that alkoxy, R stands for alkyl group, methyl, ethyl or any other group, right? Alkoxy group, alcohol after alkyne also minus I group, okay. After that amines. Next benzene. Next alkene, and least is hydrogen. Hydrogen is the least minus I group. Its inductive effect is almost zero. Which of the following is having zero inductive effect? Hydrogen. Hydrogen is not having any withdrawing power, okay. It is considered as a zero inductive group. Clear? So this is very important order. Questions came in NEET and JEE also. Once you check a PYQs, previous year questions, you will get the questions on this. Clear? These are important groups or atoms, okay. Which is having strong withdrawing power, NF3. Which is having poor withdrawing power, hydrogen, okay. You should by heart this. Clear? Right, what I will give you one suggestion to you. At the beginning, try to learn NO2, you can trick NO2, cyanide, carboxylic acid, halogens, okay, right. Plus I groups. What are plus I groups? I given already definition. Plus I groups are, what are plus I groups? Electron donating groups, right? See, O minus is a good plus I group, means its donating capacity is more. O minus, COO minus. Tertiary alkyl group, CH3 taken thrice C, tertiary alkyl. Secondary alkyl group, primary alkyl, methyl group. Next, tritium, deuterium and hydrogen. Tritium isotopes, tritium, deuterium and hydrogen. Once observe this, which is having more plus I power, means more electron withdrawing capacity. Oxygen is having more electron donating capacity, not withdrawing capacity. All these groups will donate electrons, right? Previous groups, these are electron withdrawing groups. Remember, you have to identify which is a plus I group, which is a minus I group. Clear? Let us start the applications of inductive effect. Okay, right. Applications of inductive effect. Applications of Inductive effect. Every year 2 questions are coming in the NEET exam, direct questions on the electron displacement effects, right? Maybe based on the stability of carbocations or acidic nature or basic nature. Clear? Every year 2 questions are coming, you can check the paper. Clear? Right. Let us start the applications. Okay. Right. By using inductive effect, we can predict the stability of carbocation. So I'm writing directly within the short form. By using inductive effect, we can predict stability of carbocations, stability of carbene ions, stability of free radicals, acidic nature of alcohols, same acidic nature of carboxylic acids. RCOH stands for carboxylic acid, right? Basic nature of amines. Seventh one, dipole moment. Right? Let us start first application. Stability of carbocations. See, at the beginning I give an introduction about reaction intermediates, right? What is a carbocation? Remember, what is a carbocation? Tell me. It is electron deficient or electron rich species? Electron deficient. Carbene ion is electron rich. Carbocation is electron deficient. Let us see. Electron deficient means it is needed 2 electrons to complete octet. Clear? Okay. Look at this, all of you. This is a carbocation. Okay. Around carbon, how many bonds are present? 3 bonds are present. How many electrons are present? 6 electrons. It needs more 2 electrons to complete octet. Okay. Once look at this. Here I am attaching one group, electron donating group. EDG stands for electron donating group. I am attaching electron donating group to this carbocation. What is the role of electron donating group? Donate electrons. It donates electrons, right? See the arrow mark. This carbocation requires 2 electrons to complete octet. And it is attached to electron donating group. This electron donating group donates electrons to carbocation. So carbocation will get stability. When carbocation will get stability? When carbocation is attached to electron donating group. Electron donating group means how to represent electron donating group? Plus I group. Plus I groups are electron donating groups. So when plus I group is attached to carbocation, its stability will increase. Similarly, when carbocation is attached to electron withdrawing group, EWG stands for electron withdrawing group. See, I am attaching electron withdrawing group to carbocation. See, what is the nature of electron withdrawing group? Electron withdrawing group withdraw electrons. Clear? So, it takes electrons from the carbocation. See, already carbocation is having deficiency. Already it is looking for 2 electrons. Okay, it is waiting who will give 2 electrons for it. But instead of giving electrons to carbocation, what it is doing? It is taking further electrons from the carbocation. Clear? So it will get instability. So when electron withdrawing group is present, carbocation will get instability. How to represent electron withdrawing group? Minus I group. Clear? So I will give you generalized statements. What are the generalized statements? Look at this. Plus I groups increase the stability. Plus Si groups increase the stability of carbocations. Okay, minus I groups decrease the stability of carbocations. Clear? You have to remember these two statements. Okay, what happens when plus I group is attached to carbocation? Its stability will increase. What happens when minus I group is attached to carbocation? Electron withdrawing group, its stability decreases. Now let us consider one small story to understand the applications better. Clear? Consider carbocation is the person who is going to start the business. Okay, carbocation is the person who is going to start the business. Let us consider the amount required for the business to start the business is 8 lakhs because octet means 8 electrons na. So let us consider how much rupees required to start the business. 8 lakhs, right? So what is carbocation? Carbocation is the person who is going to start the business. Okay, and the amount for the business is 8 lakhs. But how much amount he is having? That person carbocation is having only 6 lakhs. Only 6 lakhs, right? He needs more 2 lakhs, right? Means more 2 electrons. 6 electrons carbocation is having. It requires more 2 electrons. Clear? Remember that story. Look at this. See, to understand applications of carbocation, let us consider carbocation as a person who is going to start the business and going to become stability in the life. Okay, now consider what is a carbocation. Carbocation is a person who is going to start the business. Okay, the amount required to start the business is 8 lakhs. This is our consideration, our imagination. How much amount is required to start the business? 8 lakhs. Clear? But carbocation person is having how much amount? Only 6 lakhs. We know around carbon 6 electrons are present. Clear? So this is carbocation. Carbocation is the person. Carbocation who is going to start the business. Okay? How much amount he is having? Only 6 lakhs rupees. More, how much amount he needs? 2 lakhs. Clear? He has to ask the 2 lakhs. His friends or relatives. Clear? Okay. Right. Let us imagine he went to bank and withdraw that 6 lakhs rupees and waiting outside the bank for the taxi. Right? And imagine one thief is observing. One thief is observing this person. Clear? What thief will do? He will take the money from this person, from the carbocation, and makes unstable. What is our consideration? Carbocation is a person who is going to start the business. Similarly, let us consider thief as a minus I group. Thief has minus I group. Minus I group means thief. Minus I group means electron withdrawing group, na? So thief means minus I group. Consideration. We can understand easily. If we compare like this, we can understand the application part very easily. Now you tell me. Near this person, thief should be present or should not be present? Thief should be present or should not be present? Should not be present. What happens if thief is present? If thief is present near this person, thief will take all the money. Makes this person unstable, yes or no? So for carbocation, which group should not present? Minus I. Minus I group means thief. Clear? So over. So for carbocations, which group should be present? Plus I group should be present. Plus I means donating group. Minus I group should not present. Minus I group means thief. Clear? This is a simple story. Clear? Okay. Look at this. Let us consider this as story 1. Under story 1, what we learnt? Thief should not present. Story 1. Story 1 reveals that near the carbocation or in the surroundings of carbocation, minus I should not present. Thief should not present. This is about story 1. Let us see story 2. Story 2. What is story 2? See, this person is carbocation holding 6 lakhs. Okay, he withdraw money from the bank and standing outside the bank with the 6 lakhs, right? This is carbocation. carbocation, right? Two thieves are observing. One thief is observing this person or carbocation from 2 centimeter distance. Thief 1. Thief 1. Another thief also observing. Thief 2. Right? From 4 centimeter distance. 4 centimeter distance. I already explained you. For carbocation, which group should not present? For carbocation, minus I group should not present. Minus I group means thief. Clear? But in this situation, two thieves are observing to take the money from this person, from the carbocation. Due to which thief more damage will takes place to this person? Thief 1 or thief 2? Thief 1 only. Why thief 1? Because thief 1 is very closer to the person. So he catch the money and he will run away. Clear? Thief 2 is away 4 centimeter distance. So less threat. Threat is very less with the second thief. So for carbocations, minus I group should be away. If minus I group should be away, then there is no problem. See, to understand this example, once look at this, all of you. This is carbocation, right? Carbocation. Here fluorine is there, or let us take in the second position, then you can understand clearly. First, second, right? Here I am attaching, I am changing the color. Fluorine is the minus I group, thief. Minus I is at the second position, right? See this example. One, two. In the second example, where thief is, where minus I is present at the first position. See the distance. Here minus I is very closer, right? Here minus I at second position means very close. Minus I is very close here. Here minus I is away. So which is more stable? This will be more stable carbocation, because in this minus I is away. See, gap is there in between this and this, some other carbon is there, but here gap is very less. Minus I, thief is very closer to carbocation. He will take the electrons from the carbocation and makes unstable. So just you remember one point. For carbocation, minus I group should be away. Then the carbocation is stable like this. Thief should be away, should not closer. Clear? This is story 2. Clear? Right. Let us start the application. So what is important point? For carbocations, minus I group should not be present. If minus I is present, for suppose, that should be away. Clear? Right. Another story. Story 3. Story number 3. You only tell me due to which thief more loss will takes place. 2 centimeter, here also 2 centimeter. Two thieves are observing from the same distance. But you tell me due to which thief? This is thief 1. Thief 1, right? You tell me what is the difference between these two thieves? 6-pack. 6-pack. For this thief, 6-pack. Stronger. Distance is same. This person is standing outside the bank for the taxi. Okay. Two thieves are observing him from the same distance. Due to which thief more loss will takes place? Guess. 1, 2, 3. Second thief. Why? Second thief is strong, very strong person. He takes the money from this and he will run away. Okay. So why I given this example? When you have two different minus I groups in the same position, look at this. This is carbocation, means the person who is going to start the business. Fluorine. NO2. Once you see the distance, first, second position. First, second position. Here NO2, here fluorine. Distance is same only from the carbocation. In the second place, minus I. Here also from the carbocation 1 to second place. 1 to second place. NO2 fluorine, which is a strong minus I. I given the order at the beginning, sorry. Which is strong minus I group. NO2 is strong minus I group. Okay. Because of NO2, carbocation will get instability. Why? NO2 withdrawing power is more. See this. This person withdrawing power is more. So if NO2 is present, that carbocation is unstable. Okay. Both are withdrawing only, but which will withdraw more? NO2 withdraw more. Got it? Clear? Right. Coming to the examples list, right? I'll give you some important minus I groups here to do the questions, so that you can understand easily. Minus I. Few important. COH is a minus I. Fluorine, chlorine, bromine is a minus I. NO2 also minus I. Okay. But you should learn the order. I given randomly. Okay. If you need perfect order, then also I'll give you. Look at this. Based on the order, if we go back. NO2 aldehyde, ketone carboxylic acid, halogens, fluorine, chlorine, bromine and iodine. This is the order actually. NO2 is a strong minus I group. What are plus I groups? O minus, COO minus and so on. Once go through that list. Okay, clear? Right. First example. Example 1. Very simple example I will give you. A and B. For carbocations, which group should be present? Plus I groups. Which groups should not be present? Minus I groups. Fluorine is a minus I group or not? Yes, fluorine is a minus I. So this overall, this carbocation is unstable. See the stability order. A is more stable than B. Why A is more stable? In A, is there any minus I group? No. That's why this is more stable. B, unstable. Why B is unstable? Minus I group is present. See, instead of donating electrons, fluorine withdraw electrons through inductive effect, makes it highly unstable. Actually, this part requires 2 electrons to get octet. Clear? But what fluorine is doing? Fluorine is withdrawing electrons, making it more unstable. So this is unstable. Clear? Right. Second example. Carbocation, okay, fluorine, this is A. See, in A and B, same group is present, means same minus I group is present. But what is the difference between the two? One, see the distance. Let us count from the carbocation onwards. 1, 2, 3, 4. Okay, here 1, 2, 3, 4. In A, in first carbocation, minus I group is present at the second position. Minus I group is present at a second position. In B, minus I group is present at third position. What I said? Minus I group means thief. Minus I group means thief. Thief should be closer or away? Thief should be away. Then only person is stable, right? Yes or no? Thief should be away from us, otherwise thief will take money from us. Clear? So minus I means thief. Thief should be away. So here thief is present in third position. So it is stable. Clear? So B is more stable here. B is more stable than A. In A, thief is closer to the carbocation. See, gap is very less. Got it? Right. Third example. You know stories? I explained stories now. Once look at this. See this story. Thief is present within 2 centimeter distance. Thief 1. Thief 2 also within 2 centimeter distance only. Distance is same. Distance is same. When distance is same, this is minus I, this is also minus I. Thief means minus I only, na? This is minus I, this is also minus I, which will withdraw money from the person. Second thief. Why? Its power is more. Power is more. Withdrawing power is more. Now coming to the question. 1, 2, 3. 1, 2, 3. Distance is same. Third position minus I group is present. Here also third position minus I group is present. But which is a strong minus I? See the order. N-mode is a strong minus I. Its withdrawing power is more. It withdraw electrons, more electrons from the carbocation and makes carbocation unstable. This is unstable. So when two withdrawing groups are present in the same distance, at same distance, see the order. See the order. If strong minus I group is present, that is unstable. Poor minus I group is present, that is stable. Clear? So this is stable. Why this is stable compared to this? Why this is stable? Because it is having less strong minus I group. Fluorine is a less strong minus I. Clear? Let us see another example. The last example. A and B. Okay. This is carbocation. This is also carbocation. These dots represent carbon with positive charge. Consider oxygen as a minus I group. Oxygen without negative charge should be considered as a withdrawing group. Look at this. Oxygen without any negative charge is a minus I. Oxygen with negative charge is a plus I. Don't get any confusion. If you observe negative charge on the oxygen, consider it as a plus I. If you do not observe any negative charge, then consider it as a minus I, withdrawing group. Is there any charge on the oxygen? No. So consider it as a minus I group. Consider it as a minus I group. Minus I. Now see the position. Minus I means thief. See the position of thief. Where he is present. First, second, third, fourth position. First, second, third position only. In example B, thief is closer to carbocation, takes electrons and